Welcome to this video on the Agentic SDLC, focusing on engineering the autonomous software pipeline. This is particularly relevant for CTOs, VPs of engineering, and QA directors. AI code generation is rapidly changing the traditional software pipeline, with nearly 100% year-over-year growth in Gen AI projects. However, this surge creates a bottleneck, as generative AI produces raw code faster than human review cycles can absorb. Lack of governance and trust means 76% of developers resist using AI for deployment and monitoring. The verification gap is crucial. In the agentic era, code generation is a commodity, while automated verification is the competitive advantage. Without it, you face the copilot trap, leading to a 19% speed penalty. With an agentic engine, you can achieve a 2x release cadence and 90% defect reduction by shifting human effort to orchestrating autonomous verification loops. The Agentic SDLC Maturity Matrix outlines 4 stages. Pioneers, representing 38% of companies, have fully agentic pipelines, achieving 2x release cadence and significant defect reduction. Others fall into the observer, experimenter, and integrator categories, showing varying degrees of SDLC stages augmented and characteristic adoption. Quality engineering must shift from execution at scale to intelligence at scale. The old assumption of predictable systems is broken, as Gen AI introduces probabilistic outputs. To fix this, adopt end-to-end quality engineering across integration layers, which can result in up to 50% fewer production incidents. Legacy QE relies on static scripts, verifying technical correctness, and maximizing script count. Agentic QE, in contrast, uses dynamic, intelligent agents, focuses on assuring end-to-end business flows, and is outcome-centric, maximizing continuous change reliability and observability. Validating Gen AI requires shifting from deterministic to probabilistic quality. Traditional quality focuses on exact expected outputs and functional correctness. Probabilistic quality addresses the variability of Gen AI outputs, focusing on behavioral validation, continuous monitoring, and ethical boundaries to manage issues like hallucinations and bias. CI/CD pipeline failures impose a silent tax on software delivery. Developers spend 15% to 25% of their time responding to these failures, with an average recovery cost of 23 minutes per interruption. The good news is that 73% of these failures are highly predictable and structurally automatable. The architecture of autonomy is centered around a stateful remediation agent, consisting of 3 layers. Layer 1 handles detection and orchestration. Layer 2 is the AI engine for reasoning and structured prompting. Layer 3 manages memory and state, using persistence for semantic search of past successful fixes. The closed-loop repair protocol involves 6 steps. It begins with detection and parsing of failures. The agent then performs a semantic search and AI diagnosis. If a fix is generated, the agent implements it, and validation runs. If successful, it's prepared for human review. Otherwise, it loops or escalates. The ROI of autonomous remediation is substantial. Without an AI agent, mean time to recovery is 30 to 60 minutes, with high developer cost and interruptions. With an AI agent, MTTR drops to 3 minutes, cost is minimal, and night and weekend failures are instantly auto-resolved. Managing the autonomous developer requires the Human Agent Protocol. Rule 1. Verify, don't trust, by including tests for self-correction. Rule 2. Restrict and scaffold, using configuration files to limit scope. Rule 3. Manage the memory, treating the AI's context window as a highly scarce resource. The hierarchy of agentic constraints defines necessary guardrails. At the base is base configuration with advisory instructions. Next are guaranteed actions, like deterministic scripts for allowed tools. Then, domain expertise provides on-demand knowledge. And at the apex are verification loops for dynamic, independent validation. Managing agent memory is crucial due to the context window drain. Tactics include course-correcting early to stop mid-action, aggressive compaction using /clear between tasks, and delegating to sub-agents for large tasks to protect the main context window. The agentic workflow follows 4 phases: explore, plan, implement and verify, and commit. This contrasts with the legacy write, QA, fix, commit process. The agentic funnel uses iterative feedback and refine loops to achieve validated code before the final commitment. To scale output, utilize parallel agent execution. Multiply productivity by running multiple agent sessions in parallel across isolated work trees or VMs. This enables patterns like the writer/reviewer protocol and fan-out migrations for mass code-based changes. In the agentic era, code generation is a commodity. Automated verification is the competitive advantage. Strategic imperatives include funding the verification loop, stopping the measurement of inputs like lines of code, and embracing the pioneer tier of tightly coupled autonomous reasoning.